Hello everyone and welcome back. I am Benjamin Williams and today we're going to be doing another Boson NetSim lab. Today we're still within the infrastructure section within Boson, and this is actually the last CCNP lab that will be going into this series right here. And today's lab is going to be on GLBP number 3. So the objective for this lab, let's go ahead and read it. As we know, GLBP, or Gateway Load Balancing Protocol, is a Cisco proprietary first hop redundancy protocol, as well as HSRP, hot standby routing protocol. That is also a Cisco proprietary first hop redundancy protocol. So let's go ahead and read the objectives for this lab. It says, in this lab, you will configure and verify Gateway Load Balancing Protocol, GLBP environment, object tracking, and authentication. GLBP is a first hop redundancy protocol that can be used to ensure the immediate and transparent recovery from first hop failures and network edge devices by providing gateway redundancy for IP networks. You will also configure GLBP object tracking. Okay, so here is our lab topology that we're going to be working with. We have an ISP router right here, and we have three routers within the lab topology. We have R1, R2, and R3. And these are the devices that we will be configuring gateway load balancing protocol on. As we know, gateway load balancing by default, it does load balancing in a round robin fashion. So what that means is it's done in sequential order. So PC1 will go to R1 for its default gateway, PC2 will use R2 for its default gateway, and PC3 will use R3 for its default gateway. And if, say, we had 4 more PCs, we had PC4, PC5, and PC6, PC4 would then go to R1, PC5 will go to R2, and PC6 will go to R3. So it goes in sequential order, one after the other. That's the way that round robin works. Okay, so we've read through all of the commands and descriptions for this lab already. And I've also reviewed the IP address information, and this is also good information to have for troubleshooting purposes, as well as just to confirm that each interface has the correct IP address information, as well as the correct subnet mask, okay? So we're going to be doing the regular. We're going to do all of our configuration down here at the bottom. We're going to put our lab topology right here at the top left, and we're going to be doing all of our reading in the top right, okay? So let's go ahead and get into it. It says lab task. Task number 1, it says configure GLBP. It says in this task, you will configure GLBP group 10. R1 should be the active virtual gateway, AVG. You will also configure gateway load balancing protocol, load balancing, to ensure that data from hosts is load balanced across the GLBP routers in a round robin fashion. And as I just explained, round robin is the default it is the default algorithm that GLBP uses, okay? So it says on R1's Ethernet 03 interface, configure GLBP group 10 with a priority of 110. So let's go ahead and bring up R1. Let's go ahead and bring up all of our routers, actually. Where's my mouse at? Where's my mouse? Okay. R1, R2, and R3. Okay, we just brought all of those routers up. All right. So we have R1 right here. Let's do an enable. Let's do a configure terminal, and let's go into interface Ethernet 03, and let's do a GLBP for the group number of 10 with a priority of 110. All right, let's go ahead and move on to number 2. It says on R1's Ethernet 03 interface, enable AVG preemption for GLBP group 10. So let's do a GLBP 10 preempt. All right. And it says for number 3, it says on R1's Ethernet 03 interface, configure GLBP group 10 with a virtual IP address of 10.10.10.25 and start the GLBP process. Okay, so let's do GLBP 10 IP of 10.10.10.25. Hit enter there. That looks good. All right, for number 4, it says on R2's Ethernet 03 interface, configure GLBP group 10 with a virtual IP address of 10.10.10.25 and start the GLBP process. What difference do you notice about the debug output when compared with the output of R1? Okay, so we can see right here that we have changed the virtual, the AVF, or the active virtual forwarder, is now up on R1. All right, so that is good output. That's what we want to see. Let's go to R2. Let's do a configure terminal, or let's do an enable configure terminal. Let's go into interface Ethernet 03. And let's do a GLBP 10 with an IP address of 10.10.10.25 to start the GLBP process. And the question asks, it says, what was the difference you noticed about the debug output when compared with the output of R1? Okay, so we just got the output for R2. And as we can see, R2 says that it is the active virtual forwarder for number 2. It is active for the active virtual forwarder for number 2. So it has an active virtual forwarder number 2. And R1 says it is the active virtual forwarder for number 1. So that is the only difference in the output. R1 is the active virtual forwarder for number 1, and R2 is the active virtual forwarder for number 2. Okay? Looks good. Looks good. All right. Question 5 says, on R2, display a brief summary of GLBP configuration. What is R2's virtual gateway state? So if we go to R2 and we do a do show GLBP brief, we can see that its active virtual gateway state is in the standby mode. Okay, we can see that right there. Okay, and then it says the next question, it says on R1 display a brief summary of GLBP configuration. What is R1's virtual gateway state? So if we go to R1, we do a do show GLBP brief, we can see that it is the active virtual active virtual gateway, as we can see. All right, so and then we can see that also the standby is R2, because we can see its IP address, which is 10.10.10.2. So that is R2's IP address. If we go down, let's go to our IP address table. I reviewed that earlier. Look at R2. We can see R2's IP address is 10.10.10.2, and R1's is 10.10.10.1 on the Ethernet 03 interface. Okay, so it looks good. Let's go ahead and move on to question number 7. It says on R2 display detailed information about GLBP configuration. What is the state of the active virtual gateway preemption for GLBP group 10? All right, so let's go to R2. Let's do a do show GLBP. All right, and we can see that it asks what was the active virtual gateway preemption. We can see that the preemption is disabled right here. The active virtual gateway's preemption is disabled. We can see that right there. Okay. All right. Let's go ahead and move on to question number 8. It says on R3's Ethernet 03 interface, enable AVG preemption for GLBP group 10. So let's go to R3. All right. Let's do an enable configure terminal. Let's go to interface Ethernet 03. All right. And let's do a GLBP 10 preempt. All right, looks good. All right, now it says on R3's Ethernet 03 interface, configure GLBP group 10 with a virtual IP address of 10.10.10.25 and start the GLBP process. So let's go to GLBP. Let's do 10. Let's do an IP. GLBP 10 IP of 10.10.10.25. All right. And that looks good. Let's hit enter there. All right. And it says, the next question, it says on R3 display detailed information about GLBP configuration. Why has R3 not assumed the AVG role? Okay. So we see now that GLBP is enabled as the active virtual forwarder for forwarder number 3. All right. On R3. So now let's display detailed information about GLBP. So let's do a do show GLBP. Do show GLBP, and it's asking why has R3 not assumed the AVG role. Well, if we take a look at the priority, we can see that the priority of R3 is only 100, but on R1 it is 110. So that is why R3 has not assumed the AVG role, because R1 has a higher priority. Okay, so let's go ahead and move on to number 11. It says on R3, examine detailed information about GLBP configuration. Why is R2 no longer the standby router? Okay, so if we take a look, we did enable preemption on R3. So that is one reason that R2 is no longer the standby router. As we can see, R3 is the standby. And the other reason, the main reason that R3 is not the standby router, if we take a look at our IP address information, we can see that R3 has a higher IP address on the Ethernet 03 interface. It has an IP address of 10.10.10.3, which is a higher IP address than R2. And since we enabled preemption, R3 preempted R2 with the standby mode. So that is why R3 is now in the standby mode and R2 is not, okay? So number 12, it says configure PC1, PC2, and PC3 to use the GLBP Group 10 virtual IP address as a default gateway. So if we bring up PC1, PC2, and PC3, let's start on PC1. Let's do an IP config / default gateway of 10.10.10.25. Okay. Let me make sure. Let me go back up to the topology. All right. Just want to make sure that's up there. Okay. Cool. Let's do the same thing on PC2. Let's change this default gateway. IP config / default gateway of 10.10.10.25. Hit enter there. And on PC3, let's do the same thing. Let's do an IP config / default gateway of 10.10.10.25. All right, hit enter there. All right, it says for question number 13, it says on PC1 and PC2, trace the path to the ISP, which has a loopback IP address of 203.0.113.56. What do you notice about the path traffic takes from PC1 through the distribution layer in contrast to the traffic from PC2? So as we explained earlier, GLBP uses the round robin load balancing algorithm by default. So PC1 will use R1 for its default gateway. PC2 will use R2 for its default gateway. And if we were to run the same trace route on PC3, it would use R3 as its default gateway. But the question only asks us to do it on PC1 and PC2. So let's do a trace RT to confirm that. On PC1, let's do a trace RT of 203.0.113.56. All right, and we can see R1's IP address is the one that PC1 uses as its default gateway. Let's go to PC2. Let's do a trace RT of 203.0.113.56. And we can see that PC2 uses R2 as its default gateway. Okay. All right. So it looks good. Let's go ahead and move on to task number 2. It says configure object tracking. All right. So it says similar to hot standby routing protocol, HSRP, you can configure object tracking on GLBP routers in order to automatically influence elections. In contrast to hot standby routing protocol object tracking, object tracking is not used to determine which router will become the active virtual gateway for the group. Instead, object tracking is used to enable another virtual forwarder to take over for an active virtual forwarder if the weighting of an active virtual forwarder drops below a specified threshold. In this task, you will configure R1 so that R3 can automatically take over as the active virtual forwarder for R1's virtual media access control address if R1's Ethernet 00's interface goes down. Okay, so that is good information to know. It's basically saying that on GLBP, object tracker will not change the active virtual gateway, but instead